Hello YouTube! Today we're going to look at surjective or onto functions. So if you're interested in that, keep watching. Okay, so let's have a look at this problem. It says, is the function f that sends the real numbers to the real numbers given by 1 on x squared plus 2, is this one-to-one? Is it onto? Does it have an inverse? And some other questions. So let's get started. So first of all, is it one-to-one? Well, the answer to this becomes apparent when you plot it. So let's plot 1 over x squared plus 2, and let's choose a plot range x from, say, -3 to 3. Okay, let's have a look. Well, it looks a bit like a bell curve. Okay, so now remember the horizontal line test. If you draw a line horizontally through this function, does it pass through only one point? Well, the answer in this case is clearly no, because choose any horizontal line here, there's an intersection, and over here we'll find another one. Okay, so this is not one-to-one for that reason. So that means that we can easily find a counterexample. So let's just pick one. Alright, so let's just... Now here the problem is that when you put in a given value, say a, and you put in a given value, say -a, those will have the same output. You see? Okay, so this easily tells us a counterexample to the claim that the function is one-to-one. Now, let's just write out the function again. X squared plus 2. And I'm going to put replace all. And in the first case, I'll replace x with the number 1. Okay, what do we get? 1/3. Alright, now if we do the same with -1, alright, so I'll just put a minus 1 there, shift enter, we also get 1/3. Okay, so these two are equal, but 1 is not equal to -1. Alright, so let's note f is not one-to-one because f of 1 is equal to f of -1, but 1 is not equal to -1. Okay, so not one-to-one. This is a shorthand for one-to-one. Another word for one-to-one is injective. Let's write not injective. Okay, now, so we've considered the first question. Next is f onto. Another word for onto is surjective. Okay, a function is surjective if every element of the set that it gets sent to over here on the right, if every one of those elements came from an element over here on the left. Well, look, this is clear because all of the elements coming out of this function are positive, you see, because of the square. So let's note in comment form, since 1 over x squared plus 2 is always greater than 0, negatives do not come from a real number on the left set. Okay, and by that I just mean this over here. So there is no real number that gets sent to a negative. Okay, so let's conclude. So not onto, and in brackets, another word for this is surjective. Okay, so that's the second question answered. Now the third question asks, does f have an inverse? Well, the answer is no, because f is not 1-to-1. So let's note f does not have an inverse since f is not 1-to-1. Okay, so that's that answered. Now, the next question asks, if the domain of f is restricted to the set of positive real numbers, would f have an inverse? Well, remember, we have to check whether this new function is 1-to-1. Okay, so let's define a new function g that sends real numbers to real numbers by the same rule. G of x is equal to 1 over x squared plus 2. Except what I meant to write over here was positive real numbers. Okay, so I'll have a way to write that. So I mean positive real numbers. Now we need to test whether this new function is 1-to-1. Okay, so this is easy to do. Remember, what we need to do is say, assume that g of x1 is equal to x2. Sorry, g of x2. And then we need to show that x1 has to be equal to x2. So if we have g of x1 equals g of x2, well then we have 1 on x1 squared equal to 1 on x1 squared plus 2 equal to 1 on x2 squared plus 2. Okay, this is an equation, so we can take the inverse, multiplicative inverse. And when we do that, well, we have the denominators of these two equal. So equal to this. Okay, now we can get rid of the brackets. And now what we see is that we can, well, I had better put a comment around this, okay, because it's acting a little bit strange. It's thinking that I want to compute with this. So put a comment around this. Okay, now we can subtract 2 from both sides. Subtract 2 from both sides. And now we want to take the x2 squared over to the left-hand side. All right, so we have minus equals to 0. And then we factorize the left-hand side. Okay, so when we factorize the left-hand side, we have x1 plus x2 multiplied by x1 minus x2, and this is equal to 0. All right, now there are two possibilities, you see. So we could have x1 is equal to minus x2, or x1 is equal to x2. Right, but since the domain of G is positive real numbers, then we see that we must have x1 equal to x2. That's the only possibility here because we have restricted the domain. Okay, so G is 1-to-1 and has an inverse. Okay, so that's this question answered. If the domain of f is restricted to the set of positive real numbers, Would f have an inverse? Yes, it does. Okay, and finally we're asked to find that inverse. So to find the inverse, we simply we take this, we copy this, okay, and we'll go into a new cell. Let's put that right here. Right here, okay. So now rather than the left-hand side being g of x, I want to put a y. And now I need to solve this equation for x. All right, now when we solve, we'll get two answers. Okay, and I need to put an equals equals there. You see how it's red? Equals equals. Okay, so solve for x, we'll get two answers, but then when we consider what our domain is, we realize that there is only one answer. Okay, shift and enter. All right, so what we want is the positive square root. Okay, so we'll say that we get, I'll write this in comment form, x equals this when we solve this equation for x. All right, now let's turn that into an answer. Okay, so the answer to the question, what is the inverse of this new g? Okay, so g inverse of x is just this right hand side with the y replaced by x. Right, so it takes in x and it outputs this. All right, of course there are other ways to write this, and you could algebraically rearrange this. All right, but that's the answer to that. Okay, so that is all for now. Thanks for watching, and I'll see you next time. Bye.